I was on Google Earth and I came across something that I thought was pretty amazing, and that is that when you draw a path between 2 points on Google Earth, you can then ask it to show you the elevation cross section between those 2 points so you can kind of see the rise and fall of the landscape like a topographical map. So just to test it out, I drew a path from my dad's house in Denver, Colorado, to my house in Cincinnati, Ohio. And I want to show you something very interesting. When I choose to show the elevation cross section, you can see it's basically this red line. The starting point at my dad's house is 5,394 feet above sea level. And he's in Denver, Colorado, which is the mile-high city, so that's what you would expect. But then as you move east, and you can see the red arrow move east as I go that direction, the landscape starts to change where the elevation drops down and it continues to drop. You go from the foothills of the Rocky Mountains into the plains of Colorado, Kansas, into Missouri, Illinois, Indiana, and then finally you get into Cincinnati, Ohio, to my house, which is 764 feet above sea level. So what's interesting is Google Earth wants us to believe that the landscape makes this curve as shown here. But the elevation cross section actually shows that the landscape of the United States from my dad's house to my house follows this path. And most of us, when we were in elementary school, learned that the Rocky Mountains, which is close to where my dad lives, is the continental divide that divides the rainfall from east to west. I'm pretty sure when I was a kid, I've been to the Milner Pass, which is about 2 miles above sea level. And there's a sign that says the Great Divide separates drainage to the Atlantic from the drainage to the Pacific. It traverses America from Alaska almost to Cape Horn. And so that would make sense if the landscape does follow this topographical cross-section. I wanted to see what would happen when you look at the elevation cross-section over a great body of water. So starting at the northernmost point, as far as I can get, of Lake Michigan, and then traveling south, you can see that red line here, that the body of Lake Michigan is 574 feet above sea level, and it's level. There's no change in elevation. There's no curve. This cross-section shows what an undisturbed body of water looks like, and that's level. We know that to be true. There's 3 properties of liquids. They have mass, they take up space, and they always take the shape of their container. And so Lake Michigan from north to south is 574 feet above sea level. So then just to do another check, I wanted to see what the elevation profile would look like for Hudson Bay in Canada. Relatively a large undisturbed body of water. And you'll see here from the westernmost side, it shows an elevation of -2 feet below sea level, and it's level for a distance of over 879 miles. So what does all that mean? What I believe it means is that water is flat, water seeks its own level. Therefore, the idea that we're spinning on a globe is absolutely impossible.